All right, let's get right into it. We're about to dive into one of the greatest intellectual rivalries of all time. But this isn't just a story about two geniuses from the 17th century, Isaac Newton and Gottfried Wilhelm Leibniz. No, this is about two completely different ways of looking at reality itself. Visions that didn't just find new facts, they built entirely new worlds of thought. And this is the question right at the heart of it all. We've all grown up with this picture of the universe as this giant, predictable clock. But what if that's only half the story? What if reality is something more alive, more dynamic? This one question is what splits our two thinkers and sets the stage for a clash of two totally different realities. So, to really get a grip on Newton and Leibniz, you first have to understand the world they were born into. The 17th century was a time of massive, massive change. The old way of explaining everything, which was pretty much based on the ancient Greek philosopher Aristotle, it was crumbling. It couldn't keep up with new discoveries. So you had this huge intellectual void just waiting to be filled.
And the result was just a series of intellectual bombshells, one after another. First, Copernicus comes along and puts the sun at the center of everything. Then Kepler figures out the actual math for how the planets move. Galileo champions this new model, and then Descartes proposes this whole new idea of nature as just a huge, impersonal machine. The old world was being taken apart piece by piece.
And this right here is the core of the problem. The old Aristotelian world talked about things in terms of qualities. It was all about descriptions. But the new science, the one that could actually predict where planets would be, it needed precision. It needed a new language, the language of mathematics. The race was on to figure out the rulebook for this new reality. And enter Isaac Newton. If the universe was a machine, then Newton was the guy who was going to write its operating manual. He was the one who took all this chaos and hammered it into one powerful, coherent, and deeply mathematical vision of a clockwork universe. And Newton wasn't just some abstract thinker sitting in a chair. Oh no, he was a hands-on, get-your-hands-dirty kind of guy. You see it right here, in this darkened room, where he used a simple prism to prove that white light wasn't simple at all. It was actually made of all the colors of the rainbow. He literally changed how we see the world. This quote from one of his early notebooks tells you everything you need to know about his personality. He was basically saying, I'm done with old authorities. He didn't care what Plato or Aristotle said thousands of years ago. He cared about what the evidence, what his experiments were telling him right now. Truth was the only thing that mattered. And from that dedication to the truth, wow, what a system he built. You've got the 3 laws of motion, which explain everything from an apple falling to a planet orbiting. You have the law of universal gravitation, one single beautiful rule for the whole cosmos. For him, the universe was built from tiny solid bits of matter he called corpuscles, all pushed and pulled by forces. It was all predictable, it was material, and it was all math. But here's the thing. To describe this world that was always moving, always changing, the math of his day just wasn't good enough. So Newton had to invent a new tool. He called it the method of fluxions, which was his way of describing how things, like a planet's position, flow or change from one instant to the next. For him, calculus wasn't just some abstract idea. It was the language of physics in action. Okay, so at the very same time Newton is building this giant mechanical model, there's another guy, the German philosopher Gottfried Wilhelm Leibniz. And he's building something else, something radically different. He wasn't trying to describe a machine, he was trying to build a blueprint for a living, thinking universe. And at the absolute center of Leibniz's universe is this wild idea, the monad. So forget Newton's hard physical atoms. For Leibniz, monads are the real building blocks of nature. But they aren't physical at all. They're these simple, indivisible points of energy or force. And here's the really mind-bending part. Every single monad is a unique, living perspective that reflects the entire universe from its own point of view. So how does that even work? Well, Leibniz breaks it down. He says every monad has perception, an internal state that represents the outside world, even if it's kind of blurry, like hearing the faint sound of a wave in the distance. Then it has appetition, which is this internal drive that pushes it to change, to move toward clearer perceptions. And finally, some monads, like you and me, have apperception. That's actual consciousness, the ability to reflect on what's going on inside. Now, if monads don't physically interact, and that's a huge part of his philosophy, how does anything happen? This is where Leibniz introduces his idea of pre-established harmony. Just imagine you have 2 perfect clocks, and you set them to the exact same time.
They'll chime at the same hour, not because one makes the other chime, but because they were designed from the start to be in perfect sync. For Leibniz, that's the universe, an infinite number of points of view all unfolding in a perfect, pre-programmed harmony. And this brings us right back to their greatest shared invention, and oh boy, the source of their bitter rivalry, calculus. It turns out they both got there. They both discovered this incredible mathematical tool. But they did it for completely different reasons, driven by their completely opposite views of the world. And the differences are just so clear when you look at them side by side. Newton called his invention the method of fluxions because he saw it as a way to describe the continuous flow of objects in his cosmic machine. But Leibniz, he was obsessed with the idea that nature doesn't make jumps, that everything is continuous. So his infinitesimal calculus, with that beautiful notation, the dy dx that we still use today, was a language to express that seamless, universal connection. Same tool, totally different philosophies. So where did these two profoundly different approaches lead? Well, as you can probably guess, their ideas echoed through history in very, very different ways. And they ended up shaping completely separate fields of human knowledge. The contrast is pretty striking, right? Newton's legacy is concrete. He laid the foundation for classical physics that was the law of the land for over 200 years. He gave us the tools to understand the external world. Leibniz's legacy, though, is more about the internal world. His ideas about the mind and perception became the groundwork for later philosophers and, really importantly, for the brand new science of psychology. I mean, take Wilhelm Wundt, the guy who started the very first psychology lab. He looked directly back to Leibniz. Why? Because Leibniz didn't see the mind as just a blank slate waiting to be written on. He saw it as an active, dynamic process. This idea became a cornerstone for the new science of the mind. And, as a little bonus, Leibniz's work on symbolic logic even helped lay the groundwork for modern computers. Pretty incredible. So, who won? Newton or Leibniz? The thing is, that's completely the wrong question to ask. Their competing visions aren't about a winner and a loser. They represent two essential, powerful, and timeless ways of trying to understand reality. I just love this quote from Leibniz. It perfectly captures the whole spirit of this debate. He says it's as though there are all these different universes, but they are all perspectives on the same one. He might as well have been talking about his own worldview versus Newton's. Two different perspectives, just trying to make sense of the same reality. In the end, you can really boil their entire life's work down to two fundamental questions. Newton, the ultimate pragmatist, was always asking, how does the universe work? Give me the laws, give me the equations, tell me how it runs. But Leibniz, the ultimate philosopher, he asked a deeper question. Why is the universe this way at all, and not some other way? And that really leaves us with a final thought, doesn't it? For centuries, science has been all about Newton's how. But as we start to push the absolute limits of physics, of biology, of consciousness, Leibniz's why is starting to feel more and more important. The question for us is, which one of those questions is going to drive us forward now?